Welcome. We are now on page 16. This is going to be our walkthrough on covalent bonding. And quick review. So now what is a covalent bond, right? We have the prefix co, which means share. And what do we share? Valence electrons. So when we have two or more non-metals only, and they're sharing electrons, because they have too many electrons to really, lose them, but not quite enough where they can just grab them away from a metal, right? So they're going to need to share. Quick review, where are the nonmetals located on the periodic table? They are on the right side of the periodic table. And also don't forget, and hydrogen, which is kind of like on top of group 1. Doesn't belong there as a metal, but it belongs there because it has one valence electrons like the rest of the group. Okay, and again, the whole purpose is to attain a stable octet of valence electrons like the nearest noble gas. However many places away from a noble gas is going to be how many bonds something makes. So you want to make sure that you're writing the correct number of bonds in the end by checking on the periodic table. So if I'm looking over here at nitrogen, and nitrogen is 3 places away from a noble gas, neon, it has 5 valence electrons, it needs 8, right? So it needs 3 more. That means it needs to make 3 bonds. So if I'm doing something with nitrogen, I want to make sure that whatever I end up with, nitrogen has 3 bonds. So then oxygen will have 2 bonds, right? So let's take a look at our first one here. In our example, I have hydrogen, which is just 1 place away from helium, right? So it means 1 bond. Chlorine is 1 place away from argon, and it has 7 valence electrons, so it needs to make 1 bond. So if hydrogen and chlorine share together, making 1 bond between them, they each have 1 bond, they've achieved their stable electron configuration by sharing together those electrons. Right, so if I look over here, right, hydrogen and chlorine, and so sometimes we use as X's and dots. In this case, we're using the X's around chlorine to just kind of show in the share right here. This is where the sharing occurs. That one of the pair comes from hydrogen and one of the pair comes from chlorine. You can use just dots. Is totally fine. So now remember, so that this is a polar covalent bond because I have 2 different non-metals, and that means polar means different. So that means there's one of these elements is going to have a stronger pull for the electrons than the other one. And in this case, the electrons are going to get pulled in this direction because chlorine has a higher electronegativity. So we're going to give this the partial negative charge, and we're going to give the hydrogen the partial positive charge, which isn't exactly on the directions on this page, but I want to make sure that I'm giving you as much information as you might need or that you might need help on. All right, let's go for our first example. We have hydrogen. Hydrogen has 1 valence electron, so that's what I'm going to start with, is always start with your valence electrons. And I'm going to put my valence electron there. This hydrogen, and I'm just going to put them like that just so, because I know they're going to share, so I might as well just like kind of line them up to work in my favor. And now I need to, so you can do it 2 ways, right? So in the example, they do this, right? Oh, no, they don't do that. Well, they kind of ended up circling them over together, which is, I don't like to do it that way. So let's just scribble that out and let's pretend you didn't see Mrs. Davis make a mess of that. And plus, I have no idea with the screen drawing thing that I'm in right now, I have no idea how to erase. So I'm not going to bother. Let's just do over. So hydrogen with 1 valence electron and hydrogen with a 1 valence electron. So what I like to do is I like to show sharing by drawing circles. There's my shared pair of electrons. And now you can leave it like this. That's totally fine. But you can also indicate that we do this, right? It's a lot neater also. So then this represents that 1 pair of electrons. And how many things are in a pair? Or 2 total electrons. And remember, when questions ask, make sure you read carefully, because sometimes a question will ask about the total number of electrons in a bond. Sometimes they're going to ask about how many pairs. So you got to read carefully so that you answer correctly. And since this is a non-polar covalent bond, because I have two of the same non-metals, there is an equal share of there's an equal share of those two electrons. This is not an equal share up here. Chlorine's just way too greedy, right? Higher electronegativity. So it's going to kind of pull on those electrons a little bit more than that poor little baby hydrogen. All right, so now let's look at our two fluorines here. So fluorine, each of those fluorines has 7 valence electrons. So 1, 2, 3, 4, 5, and now 6 and 7. I like to show that center, I like to keep the center one to show the sharing. So now here I have those electrons that I get to share. And so now I can also read, right? So anytime I see two dots, right, on either, right, a single dot on one atom, single dot on another atom, circle those up because that's going to be where the sharing happens. So now that my circle can become a line to indicate that that's my shared pair of electrons, but I still have to include all those extra dots. These are Lewis dot diagrams. It's not a Lewis dot diagram if there's no dots anywhere, right? I do need to include those dots. Fluorine, each of these has a 4.0 electronegativity, right? So this is also a non-polar covalent bond. And again, an equal share. Because, right, I've got a 4.0 pulling that direction, 4.0 pulling that direction, that cancels each other out. So equal share of electrons. And now, does this make sense with the number of bonds that I was talking about? Looking over at our periodic table, fluorine is right next door to neon. So that means it's one place away from neon, right? 7 valence electrons, meaning 1 more electron needed. So 1 bond. Did I make 1 bond between those 2 fluorines? Yes. So then that tells me that my answer is correct, right? It's kind of a way of self-checking. Now let's go on to this oxygen. I'm looking over at the periodic table. Oxygen is 2 places away, right? So from neon, so that it has 6 valence electrons. It needs 2 more valence electrons. It needs to make 2 bonds. So whatever I draw, I need to make sure that I'm going to have 2 bonds between those 2 oxygens. And then I will know my answer is correct. So let's draw 2 oxygens. And now each of these has 6 valence electrons. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. I've drawn these a million times, so I've drawn them so that I can line them up like I like them. So now anytime I have unpaired electrons, I need to pair them up, right? They want to be in pairs and form bonds. There's 1 bond, and now here's another unpaired. I don't circle unpaired in the same atom, right? It has to be between the 2 oxygens. So when I redraw this, I make a double bond, 4 total electrons, 2 pairs between those 2 oxygens, and I can't forget those other dots. It's not a Lewis dot diagram without the dots. So then here I have those other dots. Oops, let me put that. Make sure that we go like that. Make my dots look better. There we go. Okay, now, did I make 2 bonds? I did. So my answer is right. Now let's go on to nitrogen. Nitrogen, 3 places away from a noble gas, 5 valence electrons, right? Needs 8, right? Needs 3 more, 3 places away from a noble gas, 3 bonds. So my answer should have 3 bonds between these 2 nitrogens. So I'm just going to jot that down just so that I know. So 5 valence electrons for each nitrogen. 1, 2, 3, 4, 5. Now I have another nitrogen. 1, 2, 3, 4, and 5. Let's make those. It's kind of bothering me how I'm so not artistic, and obviously you have figured that out by now. That looks like it's an extra dot, but it's not. It's just, so there we go. Oh my God, this is terrible. All right, let's partner up some unpartnered electrons. It almost looks like I'm teaching forensics, and it almost looks like blood spatter to me. So there's one bond, And now here's another one. So that one's easy. But what about that one and that one? Can I circle those? Yes, this is a two-dimensional drawing. This stuff doesn't happen in 2 dimensions. This is a 3-dimensional space. These electrons are all moving, right? They're in orbitals. Orbitals overlap, and here is that 3rd bond. So yes, you can circle those because we're just drawing in 2 dimensions. This is a model. This is not an exact replication of what happens in 3 dimensions. So 3 bonds between those 2 nitrogens. And now I still have those other electrons, and I'm going to put them here and here because, right, electrons are all negatively charged, and you want to make sure that they're spread out as far away from other electrons as possible. If you put them on top here, 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 you wouldn't be marked wrong, but I want to make sure that I'm showing them to you correctly and have how they're oriented in space. And again, this is a non-polar covalent bond because I have 2 of the same non-metals. And in this case, I have 3 pairs of electrons, which means 6 total electrons that are shared between, and I'm just going to go between those 2 nitrogens. All right, let's look at this carbon dioxide. All right, so the ones on this page, you absolutely have to be able to draw. Like it's cut and dry. You got to be able to draw all of these. And if you are having trouble drawing them, just keep practicing them over and over and over again, or memorize them. All right, so carbon has 4 valence electrons, and oxygen, that looks like a 9, but it's not. And oxygen has 6. So as I'm doing videos, apparently my handwriting is deteriorating as we go. Carbon needs to make 4 bonds also. So 1, 2, 3, 4 for carbon. And now I've got 2 oxygens. I'm just going to do them on either side over here. I have an oxygen over here and an oxygen over here. Oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and I'm just going to do that one over there so I don't put it in the middle. Okay, now doing what I've just done in all the other examples. When I have an unpartnered electron, I will go ahead and I will circle unpartnered electrons between oxygen and carbon, not between the oxygen to the oxygen, right? Because the oxygens are bonded to the carbon in the center. Right, because whichever one has the lowest electronegativity is always going to go into the center. And in this case, it's going to be carbon. How do I know the electronegativity? Right, you want to make sure that you're checking electronegativities on table S. It doesn't hurt to just look at electronegativities and just remember that it's there. So now I'm going to circle here. That's an easy one. And I'm going to circle here. That's an easy one. All right, so carbon has 2 out of the 4 bonds it needs. Oxygen has 1 out of the 2 bonds it needs. Did I say carbon has 2 out of the 4 it needs? I'm hoping that I said that. All right, so now I have 1 here and here that are unpartnered. So let's circle those up together. And now I have 1 here and 1 there together. And can I circle those up? Yes, I can. Right, remember this is just a 2-dimensional drawing. So now when I redraw, I've got my center atom carbon. I have 2 bonds to the left, right? So I'm going to go 2 bonds to the left. I have 2 bonds to the right, to the oxygen, right? To the oxygen. And then remember, I still have those 4 lone, those are called lone pairs. So lone pairs, those are my 4 lone pairs. And this is my carbon dioxide molecule. Let's check. Does carbon have 4 bonds? Yes, 1, 2, 3, 4. Does oxygen have 2 bonds? Yep, this oxygen has 2 bonds, and that oxygen has 2 bonds. Correct. So now this is a polar covalent bond because it's between 2 different non-metals. And if we're talking about the molecule and whether or not the molecule is polar or non-polar, this molecule is symmetrical. So it is a nonpolar molecule. So let's go up here because I can't remember if in the notes we've done this part yet. So then let's go down here to water. So now I have hydrogen and oxygen making H2O. So now which one has, hydrogen can only make one bond, right? Because hydrogen only has one valence electrons. It needs one more to have a stable electron configuration like helium. So hydrogen can only make one bond. If something can only make one bond, it can't go in the center, because you can't put something in the center that can only make one bond. So it has to go on the outside. So always making sure hydrogen goes on the outside. So then I'm going to make my oxygen with its 6 valence electrons, and I know oxygen has to make 2 bonds. So 1, 2, 3, 4, 5, 6. So now I have the 2 hydrogens. One of them will go here with its 1 valence electron, and now the other one will go here with its 1 valence electron, because that's where the bonding has to take place. It's the open spots on oxygen. So then I'm going to make this one a bond, and I'm going to make this one a bond, and now I'm going to redraw it. So I'm going to draw my oxygen, and I made a bond here to hydrogen, and I did a bond here to hydrogen, and I still have those 2 lone pairs. So I'm going to do those lone pairs like that. And so here is my water molecule, and this is a polar bond, right? Because I have 2 different nonmetals. And then this is also a polar molecule because it is asymmetrical. It is not symmetrical. You have to have more than one line of symmetry to be symmetrical. And let's do our partial charges. I have a partial negative charge on the oxygen because oxygen has a higher electronegativity. Plus it's got all those extra lone pair electrons near it, right? So that makes this kind of more negative, and the electrons are getting pulled. It's an unequal share, right? Because these is a polar bond. So then my hydrogen gets a partial positive. And I just want to make sure that I point out, you cannot do this. So I'm going to put a circle around that, and I'm going to make a X, because water has to be a polar molecule. If you draw it like this, it makes it symmetrical, and it's not going to be correct. Because first of all of these electrons, right, they need to spread out. So remember, water is going to be this little bent molecule. So you want to make sure that you know how to draw water. It's going to be a really important one. Very frequent question, part 2, Regents exam question, is to draw Lewis dot diagrams. Water is a very frequent question, and it's one that kids get wrong very frequently because they do this. So don't do that, right? Just making sure that you make that water molecule bent, and you're good to go. But if you do your oxygen in the correct order, 1, 2, 3, 4, 5, and now 6, you've got the 2 open spots like this and not like this, and then you're good to go. All right, so that wraps up our Lewis electron dot diagram. So if you're having trouble with these still, ask your teacher, ask myself or Mrs. Mitiga. If you're with Mrs. Main, ask Mrs. Main. Make sure to ask questions and practice drawing, because the more you practice, the better you will get, I promise. All right, until our next video, I will see you later. Bye.